Okay, hello everyone. This is the third and final tutorial video to help you complete your Hardy Weinberg Lab. This is going to be your assignment here. It's just a photograph I took of the dry erase board from last year. And so this is what you're going to do once you've created your model using the first two tutorial videos. I want you to manipulate your model to investigate how allele frequencies change with respect to population size and with respect to successive generations. Now, I know I have genotypic frequencies or genotype frequencies, but we're just going to explore allele frequencies for the sake of this lab. So you're going to create a graph to show the effect of each of these variables, both population size and multiple generations, on allele frequencies and to discuss the results. So as in a product, you need to create two graphs showing each of these. And you don't need to include your lab notes, but I would like you to generate a discussion based on what you found. So how does population size influence your allele frequencies? How do successive generations affect your allele frequency as well? So that's what I'm going to be looking for as a product, and I'm going to show you how to get there. This whole thing is a workbook, and this is a worksheet that I'm on right now. I'm going to go to my populations worksheet, and from tutorial video number 2, I showed you how to generate this. And one thing I want you to do before you get started here is, you notice I had 0.5 before, and what I did was I went through, and if I change this, I wanted all of these others to change. Notice, remember, we just put a random number or whatever. You chose one between 0 and 1, and then you put this as equal to 1 minus whatever you put in there. But if you change this, you happen to just see, well, I wanted to see if I change the expected frequencies, what would happen. To connect all those, you simply need to highlight the cell, and it said probably 0.5 or whatever you put in there originally, and hit the equal sign, and then just highlight that cell with the first frequency of a data cell. In mine, it happened to be D2, and I just hit that, and then hit enter. And so what I'm going to do is go back through and hit equal D2 because that's the cell that I want it to follow, equals D2, and I've already done that with these. Oops, I made a mistake, so I got to back up, got to get off that. Is equal D2, 5 of those. That's what I'd like you to do first. Now you'll notice that if I ever change this, let's say I change it to 0.3, this changes to 0.7, and all of these follow suit for all of my populations. Those are all the expected allele frequencies. Okay, so it stays consistent. Now, what we want to do is we want to compile our data for each one of those different populations. So I'm going to go down here into some open space, and I'm going to enter population. And my next heading is going to be frequency. Okay, so it's going to be frequency. And hit those. You can stand as my headings, headers. Population size I started with 16, and then I went up in 20, so I'm going to enter 16, 36, 56, 56. So those are my 5 different population sizes. Hopefully it chose something a little bit bigger and went up in like 50s or 100s. So what was my frequency of A when I ran my population size at 16? Well, here it is. So what I'm going to do in this cell is I'm going to hit equal sign. I'm just going to select that cell. Right here. Sorry, that's the number of each allele. I want the frequency, it's right here. And then enter. And for frequency of B, which is actually also Q, this cell. I'm going to do that for each of the population size, so now I got to go over to my 36 population size. Equal. Frequency of P for that. And that's what I want. slide back and forth here. So now I'm on my third one. 2, 3. Equal sign. Q value. Population size, which was 76. Just 2, 3, 4. Sliding down. Equal sign. Go back to 2, 3. The reason we're doing this is because Excel does not like it if you just start highlighting individual cells. They want all this stuff condensed and put together. So for population size 16, the frequency of A was 0.25 and frequency B was 0.75. You'll notice that we had expected a 0.3 and 0.7 based on what I put up here. So it's relatively close. All right. So what we're going to do is we're going to make a graph of this. But before we do that, on your graph, I want you to have what the expected frequency of A was, so that we have some lines to compare to. We're going to make another heading that is expected. EXP A. Expected frequency. I'm going to highlight those, or I'm going to boldface them to show their headings. For every single one of our population sizes, we had the same expected frequency for A, and it would have been 0.3. So what I'll do is I'm just going to hit the equal sign, and that's up. It seems like I just draw that down. Get 0.3 anymore, so we can't do that. I'm just going to delete these. Here's that. I don't know the way around this, but we're going to have to go up and click that sign. Or you could just put D2. So do that equals the actual cell, which is D2. .3. In this one, it is, for me, it's cell D. This is like orientation, so column D, row 3, D3. D3. The reason that we couldn't just drag it simply down is because the computer thinks that we need to do consecutive, and so it's not going to work out. So that's why I did the trade separately. Now we can make our graph. And the way we're going to do that is we're going to highlight all of these, not our population size. And we're going to go to insert, do line graph, two-dimensional line. We can see, let's make this as a bigger graph. So I'm going to right click into an open area and go to move chart. I'm going to put it into my own sheet. I'm going to title this right away. This is going to be our population graph. You can see that the expected of A was a green line, whereas the actual frequency that we saw was a blue line. And our expected for frequency for B was this purple line straight across. And the red line shows how close it came to what we expected. Now you can see down here that we have 1, 2, 3, 4, and 5. Those are actually. Anyways, I'm going to click on that and I'm going to go to select data. Go to horizontal axis labels and back to our population page. And I'm going to highlight all of the populations 16 through 96. Enter. And hit OK. You can see it's on 16, 30, 56, 76, and 96. So that's exactly what we want to do. There's things in this graph, and the way you handle that is you go to chart tools, go to layout, go to a chart title. What to do above the chart, you can enter it in this field or you can type right in words that we're going to have a title of male frequencies with respect we might want to say the effect. Another way you could do it is, another way you could say this is effect on allele frequencies is and now I'm going to go to access titles. I'll do my vertical one first. I always like the rotated title. And I'm going to name that allele frequency. It doesn't really have a unit, it's like a percent, but these are not converted to percentages. We're going to leave that as it is. And then we're going to go to horizontal axis title. This would be I noticed that our title is pretty big, but it's hard to make out the individual labels. So it's pretty good. It's pretty good. That graph looks pretty well. How would you interpret something like this? Well, our purple line, remember, was our expected frequency for allele B. And it was supposed to be 0.7 for every single population. Notice the red line and its proximity to that purple line. Does it seem as we increase population size to get closer to what our expected was? And I would say yes, based on what I'm looking at here. It looks like the deviation from that line appears to be smaller as the population increases. Is that the same? Is this same true for our frequency of allele A? And our expected was this green line, which was 30% or 0.3. Does the blue line seem to be closer to that green line as we increase the population size? It appears to be so. Okay, so that's the pattern I noticed. So that's a graph that I would print out for the effect of allele frequencies by changes in population size. But I'll do one more graph, and that's the effects that generations, multiple successive generations, what effect do they have on your allele frequencies? So we're done with populations. We're going to you notice the thing that's different about this is that our population size is the same from generation to generation. We only want to change one thing to see what effect it's going to have on allele frequencies. Now I'm going to do the same thing here. You notice I have 0.4 and 0.6. So I'm going to make this equal to a cell because V2. You can see that's going to match up. So I'm going to go back through to equals V2. And a couple more I need to do here. I'm going to keep it, actually, we had 0.3, so I'm going to stay consistent between the two tests. Now this is the model. Remember, it's a random number generator. Each time we hit it's going to randomly generate some numbers here. If you look at the homozygous dominance, there's one here. 1, 3, and 12, 1, 8, and 7. So it changed each time I did a different generation. Okay. I'm going to do something similar. I'm going to do just the generation. They're observed frequencies. Expected frequency of A. And expected frequency of B. These are all letters. So we had first generation, second, third, fourth, fifth generation. Okay, so the first generation is right there. So we got to hit enter. So second generation, slide over. Get the Q from the second generation. Third generation. So I'm now going to go over 3. 2, 3. 3. B. Generation. So 1, 2, 3. There we have it. Now we need the expected frequency for A. Remember that was in D2, so I can do the same thing I did before, equals 2. Okay, and then D3 was our frequency of B or Q. That's what I'm going to hit equals D3 now, just as I did then. And there we have it. And we're just going to make a graph just as we did with the other one. Select these. We're going to wait on generations. Choose line. Define. And we're going to go back to chart. It's on sheet. We're going to name this generation graph. And we're going to go back and change some titles. These are fine because they've got them as first, second, third, fourth, assumes that each plot point is considered. We don't really have to change those like we did with the other one. Here. Charts. I might have messed up the title from the last graph. We'll go back and fix that right now. That was not worded very well. Let's go back to populations graph. calculation. Okay, so I'm happy with that. Back to my generation graph. And now I need my axis titles. Again, it's going to be horizontal. This is going to be vertical. And I'm going to go back through and I'll change the size of these. I need to click on the home key to get to that. This is pretty good. You can play with different format. How would you interpret this? Well, does it have a general trend to get closer to what expected is? We have expected is line here, expected is a green line for A here. Does it appear to get closer as we go through six? Hopefully, at the tail end, the fourth and fifth generations would be closer than. I would say that maybe if we did more generations, we would be able to see this. But in general, we don't see a real connection between which generation you're on and what the allele frequency is going to be. So it doesn't seem to have a pattern of what generation we're on compared to what we expected and what we see with our random number generator. Okay, so I would print out this graph, print out this graph. I would even like to see you print off your data. I'm going to do that actually. That's quite a bit of information. What you could do is you could take this data here, you could copy it, you could paste it onto a separate sheet or Microsoft and go back to your generations and copy this as well. And paste red lines into it. And the way you can do that is format border. And you can copy and paste that into a Word document, wherever you want to put it. But I like to see that data that you've pushed together, so I can compare that to what's going on in your actual graph. If we can copy this and then just put in your graph world generations. Maybe can. It's not going to work. So you could put those, you can go back and you can put these into the see that as well as your discussion. Yeah, I hope that helps.